So that was kind of fun. He was also the one who started the Berlin Royal Society, but he was never allowed by the Duke to go and participate. So even though he was the one that got it started, and he was officially the president of the Berlin Royal Society, he never actually had a chance to attend it. So that's kind of another crazy thing. He was the kind of person that talked at parties all the time and didn't notice what the people were listening to. You know, while he was talking, somebody would ask him a question and he would answer it forever. And meanwhile, that person left and someone else came by, and that person left and another person came by, and he was still answering the question, whoever would listen. So he was kind of that kind of a strange kind of person. So Dr. Pangloss in Candide is kind of an approximation of what he's like. He's kind of the kind of genius that everybody makes fun of, because he's probably, I guess if you're familiar with Elon Musk, right, the current richest guy in the world, you know, that doesn't have like a social personality. You know, he comes up with great ideas. Let's go to Mars. You know, let's build our own rockets instead of, you know, following the plan. You know, whatever, all kinds of things. But when, you know, his various wives talk about him and everything, they explain how he's not right in the head. You know, he's weird when it comes to, you know, social. He says whatever he feels like, no matter whether he should or not, right? You know, he doesn't have a sense of, you know, how he's going to insult the person, etc. Probably Leibniz, I think, was probably something like that, which means chances are he had something like Asperger's. You know, if you would you know, update, you know, the mental description of him today. When he died, the only one that noticed it was his butler, and his funeral was attended only by him, the butler.
I thought you meant.
Well, I don't know that you can attend your own funeral, I suppose. You know, but yeah, no one else was there. The Duke was hunting that day, and was more interested in the hunt than going to see the funeral of his counselor, etc. So, kind of an interesting person. But let's talk about some of his arguments. There's just all sorts of things, but I'll talk about the best of all possible worlds. So one of the things that Candide is making fun of is that Leibniz says that this is the best of all possible worlds. And as far as Voltaire was concerned, well, gosh, they just had the earthquake in Portugal, Lisbon, and all kinds of people died. I mean, you know, there's plague, there's all these different things that go wrong. How on earth could anyone think that this is the best of all possible worlds? Well, my understanding of what Leibniz is talking about is the same as Brian Greene. The extra E is on Greene, not Brian. And I don't know if I'll be able to find string theory. This looks like it.
There were many people around who thought that project had already been resolved. Newton had given the world a theory of gravity in the late 1600s that works well, describes the motion of planets, the motion of the moon, and so forth, the motion of apocryphal apples falling from trees, hitting people in the head. All of that could be described using Newton's work, but Einstein realized that Newton had left something out of the story, because even Newton had written that although he understood how to calculate the effect of gravity, he had been unable to figure out how it really works. How is it that the sun, 93 million miles away, somehow affects the motion of the Earth? How does the sun reach out across empty, inert space and exert?
And by the way, even though we still use gravity and talk about gravity, sometimes even comically, the explanation that we get from Einstein is that space is curved. And so that everything is moving in space, so the Earth is moving in its path, you're moving in your path, and it just so happens that your path and the Earth's path coincide just close enough that you're constantly pushing against the Earth, and the Earth is accelerating you, right? And so the reason you feel the pressure of the Earth is because it's pushing you, right? And that's because it's going on its path and it's pushing you against your path, right? So the reason you feel gravity is because of this acceleration that we get, right? That's the Einsteinian explanation of gravity. There is no real gravitational force. It's instead the way that everything is moving in space that causes these kinds of semi-collisions, in a manner of speaking, right? So that's that. But where this, I think it's this video, but in any case, what he'll explain is that there's actually, theoretically, multiple universes out there, right? Just as Einstein, just as Leibniz argues, of all possible universes, this is the best possible one, right? And what Brian Greene argues that, if you had just the slightest difference in how the different masses work and how the relationships in energy work, this universe wouldn't have had stars, it wouldn't have had planets, it wouldn't have had Earth with the chemicals that we have, we wouldn't have had life. So of all the possible universes, this is the only one that would have ended up with life as we know it. So this is the best of all possible universes. That's Brian Greene's point, right? Well, that's precisely, I think, what Leibniz was saying. He's not saying that this is the best, of all possible worlds where everybody's going to be perfectly happy, and it's kind of a Rousseau idea that living in the woods and making your own house and chopping your own wood, that's the best kind of life, away from government, etc. That's kind of Rousseau. But that wasn't really what Leibniz was talking about. He was talking about the idea that of all the possible, and the reason for it is, well, God made it. God was all good, all perfect, and created this earth, so therefore this must be the best of all possible worlds. Because he wouldn't have made one that was more defective than it could have, right? So obviously this has to be the best of all possible worlds. Doesn't mean that everybody's going to be happy with this life, or that everyone's going to be rich or famous, etc. Obviously that can't all happen, right? So that's not the point that he was making. So Voltaire is making fun without at the same time indicating that he understands what he's making fun of. So the best of all possible worlds, right? The other, and the one that I suggested everyone take a look at, is the monadology. What is the monad? Monad is Latin for atom. So basically, it's the smallest possible thing. And what's neat about his definition of this is he takes it from the elements of Euclid. This is something else I should have thrown at you while we were passing him by. Euclid is after Aristotle, but we still use Euclidean geometry. And just as Spinoza was pointing out, we've got the definitions of things, and based on the definitions, then we have the axioms, and then based on those axioms, we have the kinds of propositions that we can make. And so you have a point is that of which there is no part. A point is that which has no parts, essentially. Remember when we were talking about Plato and his conception of the soul, he told us that the soul is that which has no parts. So essentially the same argument applies not only to points on a line, because when you talk about points, strictly speaking, a point has no parts, right? It's not really there. It's, would have to have shape, etc., and if it does, then it would have parts, right? But it doesn't have parts. A line is a length without breadth, right? And the extremities of a line are points. So this is actually a line. If I draw a line, that's not really a line because you can actually see that it has depth, right? And a real line doesn't have depth because it has the points that have no parts, etc. But in the monadology, simple substance, and it means, well, without parts, right? So it has no parts. Now, when we think of Locke, John Locke, and his materialism, he thought of the atoms as having no parts, but as being a solid that had shape, etc. So the difference between Locke and Leibniz is that what they consider to be the smallest possible thing is for Leibniz that they have no substance, in a sense, right? It's such a simple substance, it really doesn't have any material in it. Whereas for Locke, it does. And in fact, these things are almost souls, if anything. They're closer to what a soul might be called than an atom, right? Now, the neat thing about today is contemporary physicists like Brian Greene and others are basically in agreement with Leibniz. So when we're thinking about the nature of substance today, and we do break it down into atoms, molecules, atoms, but the atoms themselves are broken down still further, right? And those atoms are broken down into what we call the standard model of physics, right? Which, I don't know how many of us practice memorizing the standard model or whatever. But theoretically, we have these subatomic or elementary particles, right? They're subatomic, so substance or matter only starts at atoms. If you're subatomic, then it's not matter, right? So it's kind of confusing. They're like souls. They're energy, right? And not matter, right? So these are all aspects of energy, right? We have the quarks, which are the purple ones. We have the leptons, which are the green ones. The bosons, which are the orange, and the Higgs, which is the newest one that they just found. It's kind of interesting. It's supposed to explain a lot that they were wondering about. I don't know if they're going to find more, but at least right now, I think they found all the particles that their theory predicts. But these particles are basically just like the monads that Leibniz describes, as opposed to the atoms that John Locke describes. So at the current moment, Leibniz seems to be more in And a lot of physicists are interested in him, and so they're trying to figure out what was he really talking about, because when you think about how his monads work. Oh, wrong. Let me get to